Okay, so this is the first question of section 1a. So we suppose a and b are real numbers and they're not both 0. And that's just because we don't want this denominator to be 0 and then we get an undefined fraction. We want to find c and d such that they're real numbers and such that 1 over a plus bi equals c plus di. So that's just the textbook question. So this is just a basic algebra exercise, really. So multiply both sides by a plus bi, and you get 1 equals c plus di times a plus bi. So that's multiplied over. And then expand that so that you can get a complex number, and you get this complex number here. That's a complex number. And then you can match up the real term and complex term with your left-hand side. So CA minus DB would be 1 equal to 1, and 0 equals CB plus AD. Right? Okay, and then you can solve for C and then substitute into the other to get rid of the C's and D's so that you have it only in terms of B and A. So solving for C, you get 1 plus dB over A, and I substituted that in for C over here. So C is this entire bit in here. So I substituted in and expanded. Get this. Then I multiplied across the a squared so that we could get rid of the fraction. And then I realized that you can factor out the d. And then, then you've got d equals, and then in terms of b and a, and then you've done d. So just substitute this in now for the c expression for c you got previously. And do algebra. So what I did was turn this numerator bit into a single fraction. Right? And once it became a single fraction, it simplifies down to c, and that's the end of the question. Leave any comments if you're confused anywhere. I'll see you in the next one.